I hope you're having a great day. This is Parth Sane, and this is my presentation for the conference. The topic of the presentation is, as you can see on the screen, is the OWASP top 10 list comprehensive enough for writing secure code? That is the title of my paper, and I'm going to describe that further. So in this paper, the Open Web Application Security Project OWASP publishes a well-known list of vulnerabilities ranked in order from 1 to 10, and primarily the goal is to have developers know what to look out for so that they can avoid getting software exploits for their the piece of software that they're writing, and then it actually works out in their favor so they don't get hacked. And this data set for this particular project was gathered from the National Vulnerability Database published by the US. And it has CVE and CWE numbers for each list of vulnerabilities that are described. So in order to extract the data, I had to do some standard extract, load, and extract, transform, and load ETL transformations. And part of that involved doing data normalization, data adaptation, data extraction, data conversion, data interpretation, which are the standard kind of presentation or like processing that you have to do on the particular piece of information that you have to work on. Excuse me. So next, we are trying to see in the paper what are the research questions answered, and what are the top 10 reported CWEs of the past 10 years in the National Vulnerability Database. That's one of the questions, and the other one is what are the CWE IDs for vulnerabilities described by OWASP top 10, which is the highest reported CWE in the past 10 years within the National Vulnerability Database, and is it the same as the OWASP top 10 rank 1? How many vulnerabilities with respective CWEs in a National Vulnerability Database are actually present in OWASP top 10 CWEs? These are some 4 research questions I try to target for the paper and see if we can answer them with the data that we have from the NVD website and database. And this is a sample piece of code snippet which I had to use for creating the numbers and analyzing things. As we can see, it was pretty standard data science libraries like pandas, and then the JSON package that Python provides for analyzing the data, because the data is in JSON format, which comes from the NVD database. Some of the results really are interesting, and we as in I was able to get that in the CVE counts in the Excel sheet here. I worked on this particular project after completing my master's degree, but I was actually working on this as part of a class project for which I actually converted into a paper at the end of it. And my professor was very helpful in understanding an idea for this and how to do this and all the other specifications. Results, we can see these are two figures that are present in the paper. As we can see, one is just the count of the common weakness enumeration IDs in the NVD for all vulnerabilities, and then we are looking at what are the CVE IDs for OWASP top 10 vulnerabilities. So which one from the set of OWASP top 10 vulnerabilities is most common, and then which one is overall common for the entire database, or the most numerous. This is kind of a high level overview that we are able to see. There are also some limitations to this study, and the limitations are primarily with respect to some considerations which we have to keep, or caveats which we have to keep in mind when we are analyzing these vulnerabilities. The NVD database doesn't really consider whether the weaknesses from desktop systems or mobile devices or any kind of differentiation on the platform, because different platforms may have different kind of vulnerabilities, even though they may have similar weaknesses. Also, we don't single out applications that may be the worst offenders in the number of vulnerabilities. We don't want to point out that one particular software is bad or one particular software is good. We're only trying to point out, which particular pieces of software, are, I would say which particular, but the point is which software is actually vulnerable to what, and what is the high level overview for the past 10 years. And OWASP Top 10 only considers web application security, domain of computing security. Hence, we have to remember that the analysis of this is not exhaustive but empirical. We are trying to see a high level overview of 10 years, what people are doing, and do we need to have any further recommendations for software engineers to not repeat them? I myself am a software engineer, so I like to keep secure coding practices in mind when I work on my projects at work. And there's also a significant overlap between the NVD and the top 10 list, and thus this paper is valuable in analyzing trends, even though we are only considering the web application security domain of computing security with the OWASP top 10. There is still overlap, so that's useful. And that's actually much all about my paper. And thank you. If you have any further questions or concerns, please feel free to ask me. I'll be here. Thank you for your time. Have a great day.